Good morning, everyone. Today, we'll be discussing about X-ray film processing. You're all familiar with the term X-ray receptors, also called as image receptor. Now, what is an image receptor? An image receptor is defined as a device that can change an X-ray beam into a visible image. In dentistry, we have various dental image receptors. It can be a conventional X-ray film, a screen film combination, or a digital sensor. As you can see, these images represent your X-ray films, that is your intraoral radiographic films, or your conventional radiograph, or the digital sensors, the various sizes of digital sensors that are available, size 0, size 2, or even a size 4 occlusive digital sensor. Today we'll be focusing primarily on the X-ray film processing. This is applicable for your conventional radiographic films. Now, your film processing, we have divided them into an introduction about the latent image formation, a little bit about how your darkroom should be, what are the various steps of processing, what you should be knowing about the solutions that we use for X-ray film processing, mainly your developer and your fixer solution, and the various types of film processing that are available. So as we said before, an introduction into your latent image formation. Now, a radiographic film, that is your conventional X-ray film, is a recording medium. Now, once this X-ray film is exposed to information, this information is the beams of photons, that is your X-rays, as they're exiting from an object. Now, you're all familiar with the parts of a radiographic film. It has an outer polyvinyl cover. Then there is a black paper in it. Within this black paper is your lead foil and finally your radiographic film, the base with emulsions on both sides. Now, the emulsions that are there on both sides consist of silver bromide crystals and silver iodide crystals that have been precipitated in a gelatin, and this is laid on the transparent base on both sides. Now, this silver halide crystals have imperfect aspects, which is chemically sensitized by sulfur compounds. That is physical irregularities that is there in the crystal produced by the iodide ions, forming your latent image sites. So, this latent image sites, they function as the area where the process of image formation happens by trapping the electrons when generated or when radiated. Now, a latent image is an invisible change that happens in the silver halide crystals. So, a latent image formation is your invisible image formation, which happens in the emulsion that is there in your radiographic film. Now, it is the processing solutions that help in the conversion of these crystals with the latent image and finally giving us a visible image that is something we can see with the normal eye. Now, all this processing of the X-ray film happens in a dark room. So, dark room has certain requirements. There's a function. The main function of the dark room is that it should be a completely dark area where you can do the conventional X-ray film handling and processing. The darkroom should have an ideal temperature of 70 degrees Fahrenheit. The temperature should not exceed more than 90 degrees Fahrenheit. The humidity also in the darkroom should be ideal, approximately 50 to 70%. Now, why we are concerned about the temperature and humidity is because if the environment in the darkroom is too dry, it can give us a static electricity artifact. If it is too moist, it does not cause the drying of the emulsion. Even though it is called as a dark room, we need something called a safe lighting in the dark room. For the safe lighting, we require an incandescent bulb of 15 watt, whether it's for an intraoral radiograph or an extraoral radiograph. Now, this safe light should not be placed very close to where the work surface is. From the work surface, the safe light should be at least 4 feet away. Now, moving on in detail to the various steps of film processing. First is the wetting, then the developing, then the rinsing, fixing, washing, and finally drying and storing of these conventional X-ray films. So let's move on and see what are the various processing methods. Now, X-ray film processing can be done in two methods. One is your manual processing, next is your automatic processing. In the manual processing itself, we have the time temperature method which can be utilized, the visual method, or the rapid processing method which can be utilized for X-ray film processing. Other than the manual processing methods, we also have the automatic processing, the self-developing films, and the digitalized processing method. We would be focusing mainly on the manual processing methods, the automatic processing methods, and about the self-developing films. In the manual processing methods, we would be focusing on the time temperature method and the visual method. As we already said, for the processing of X-ray films, we require two main solutions. That is the developing solution and the fixing solution. So we need to know what are the components of the developing solution. The developing solution consists of four main parts. That is your developer or the reducing agent, mainly the hydroquinone or the phenadiene. Then there is an activator, that is your sodium or potassium hydroxide. There is a restrainer in the developing solution, that is your potassium bromide. Then there is a preservative, that is sodium sulfite. The fixing solutions also have four main components. That is your clearing agent, that is ammonium thiosulfate, acidifier, which is your acetic acid, the hardener, that is your aluminum sulfate, and the preservative, that is ammonium sulfite. Moving on to the steps in film processing, as we already mentioned, there are 5 main steps, that is the wetting, developing, rinsing, fixing, washing, and drying. So let's start with the first step, that is wetting. In the step of wetting, it's the film emulsion that is softened. When the various chemicals that are there in the developing solution act on the emulsion that is present on the film base. Once the wetting has happened, the next is your developing of the silver ion and silver halide crystals. And this developing in the developer solution happens for or it should be immersed for an approximate of 20 to 30 seconds. Now, if more time is used for developing, there are chances that more silver will precipitate, giving you a denser complex, or the net result would be a darker radiograph. If the time is reduced, then there are chances that it would be a less dense structures or comparatively a lighter radiograph. Once your wetting and developing is complete, you need to wash this radiograph in a clean water. This helps in suppressing the developing process. Then you need to fix this radiograph. In the fixing process, the undeveloped, unexposed crystals are removed from the emulsion, converting to a soluble silver salt by the fixing chemicals. Now once this happens, once it is completed, you can read the radiograph. That is wet reading. This process is called as the wet reading. That is done immediately. That is 3 minutes for viewing after the fixing has happened. For permanent fixation and keeping it properly, you need to fix it for a minimum of 10 minutes. Once this is done, you can wash the radiograph of any excess chemicals, and then you can dry it and store it as per as your requirement. Now, the various methods of film processing. The first one, as we said, is the manual method, which has the time temperature method. This is advantageous when you want to process mass radiographs, a numerous number of radiographs. But the main disadvantage with it is the films cannot be viewed during processing. And it takes a little more time for drying. Now, as the name suggests, time temperature. So for a specific temperature, there is a specific developing time and the fixing time. As you can see, if it is 65 degrees Fahrenheit, you need to develop the film for approximately 6 minutes, rinse it in water for approximately 0.5 minutes or 30 seconds, and fixing time is 10 minutes, after which you can wash it for about 20 minutes. If the temperature is higher, if it is 70 degrees Fahrenheit, the developing time is 4.5 minutes. The rinsing time remains the same, that is 0.5 minutes or 30 seconds. But you can see that the fixing time again has reduced to 9 minutes. So in short, as you can see, as the temperature increases, the developing and the fixing time reduces. If the temperature is 75 degrees Fahrenheit, the developing time is 3 minutes and the fixing time is 7 minutes. So, if we are following the time temperature method for manual film processing, ensure you have a thermometer and a timer in your darkroom. For the manual processing, if you're using a visual method, you can place the films directly into the developing solution once you've taken it out from the outer cover. And this film, after its placement in the developing solution, is intermittently viewed under safe light. So the degree of development that happens in the film is based on the operator's discretion. So the main advantage is you can avoid overexposure of the film. But the main disadvantage is each film needs to be given its time, and therefore it's a time-consuming process. Next is a word about your automatic processing. Automatic processing, as the name suggests, is done with the help of an automatic processor. This is the diagrammatic representation of an automatic processor. Here you can see once you've opened the X-ray film out from the cover, you can put it into the automatic processor. With the help of these rollers, the X-ray film moves on to the developing solution. Again, with the help of the rollers, once the development has happened, it moves on to the fixer solution. Once the fixing has happened, it moves on to the water where it is washed and moves to the drying area, and finally you receive a developed dried film. So the main advantage of automatic processing is rapid processing happens, that is within 4 to 7 minutes you can get your dried radiograph. You require much less space. You do not require larger tanks. You just need to fix in the automatic processor. And no wetting of the films before starting of processing is required. And no film hangers are also required as you get a dried radiograph. But the main disadvantage is it's more grainier. The automatic processor are not very affordable. They are expensive and you need to maintain them very frequently. Last but not the least is your self-developing films. As you can see the diagrammatic representation of the self-developing film. There is a developer tab, then there's a developing solution, a metal strengthener, then a fixer solution, a fixer tab. And all this is kept in a plastic sachet with your X-ray film. So once this X-ray film is exposed, the developer solution is released through the plastic sachet and it helps in developing of the X-ray film. After a few seconds, the fixer solution is released, which helps in fixing of the X-ray solution. After this is completed, you remove the film from the sachet and wash it in running water. And you get a developed X-ray film. So the main advantage of self-developing film is you do not require a dark room. Therefore, the processing is much faster and comparatively time-saving. The main disadvantage is since the developer and the fixer solution react on it together at a certain point, the image deteriorates rapidly and the film packet is flexible and can be bent easily, causing bending artifacts. This self-developing film is a little difficult to use in position indicating devices, and the film as such is relatively expensive. Thank you. That was about your X-ray film processing. Hope you all have a good day.